Pandas, mapping, replacing, and applying functions. Welcome! In this lesson, we will explore how to transform data using three powerful Pandas techniques: map, replace, and apply. These operations help you quickly clean, enrich, and customize data frames. All examples use the TIPS dataset so you can relate it to real-world business problems. Running the cell now. Let us get hands-on with the data now. First, we will prepare our environment by suppressing unwanted warnings, then load our data. Warnings are turned off to avoid clutter and to keep our focus clear. We bring in Seaborn so we can access its built-in example datasets. Import NumPy as NP. We set the random seed to 42 for reproducibility. Now we load the TIPS dataset into a data frame so it is ready to use. We see how many rows and columns are in the dataset. We also show the top 3 rows to get a sneak peek at the data. Running the cell now. This output shows the initial structure of the TIPS dataset with 244 rows and 7 columns, including total bill, tip, and customer details like sex and smoker status. Noticing the shape and the first few rows helps us understand what kind of data we are working with before applying mapping, replacing, or custom functions to clean or transform these columns. This foundational step ensures we know the dataset's layout as we move into data transformation techniques. Take a moment to notice the columns. Can you spot how gender and time of day are recorded? Why use map, replace, and apply? The map method is great when you want to transform values in a series using a mapping or a function. The replace method finds and swaps values in either a series or a whole data frame. The apply method lets you run custom functions column-wise or row-wise across data. These tools can help you with label encoding, flag creation, standardization, and more. Running the cell now. Let us start with mapping categorical values to numbers. Now, let us see how to turn text labels into numbers for analysis and machine learning. This comment reminds us we are mapping gender labels to numeric values. We create a mapping dictionary: male becomes 0, female becomes 1. We use the map method to convert that sex column to numbers and store it as sex_num. We display both the original and new columns for comparison. Running the cell now. Here, the map method converts the categorical sex column into numeric values using a dictionary, producing a new sex_num column. Notice how female becomes 1 and a male becomes 0, which is essential for feeding categorical data into machine learning models that require numerical input. This shows how map efficiently transforms values based on a predefined mapping. Can you imagine how this helps algorithms understand gender information? Let us practice by mapping smoker status next. This tells you what we are about to do: map smoker status. We define the mapping so that NOA becomes 0 and ES becomes 1. We use the map method to create a new column called smoker_flag. The output shows both original and mapped smoker info side by side. Running the cell now. Here, the map method converts that smoker categorical values into numeric flags using the dictionary smoker_map. Notice how no gets replaced with 0 in the new smoker_flag column, making it easier to quantify smoking status for analysis. This demonstrates map's power to quickly transform series values based on a defined mapping. Try mapping the day column to a number 2, using a custom mapping. Now let us try something similar for days of the week. This comment sets context: we are mapping days to numbers. We make a dictionary matching each day string to a unique number. The map function changes the day column to its number version. We display the result to see before and after side by side. Running the cell now. This output shows how the map method has transformed the day column into numerical values based on the day_map dictionary, creating a new column's day_num. Notice that all sun entries are correctly mapped to 3, demonstrating how map efficiently replaces categorical labels with numeric codes, which is useful for many data analysis or machine learning tasks. Notice how easy this makes sorting and arithmetic on days. When should you use map? Use map when you have a single column, series, to convert. You have a rule or dictionary to apply. If you need to update several columns, or to replace values in place, try replace next. Running the cell now. Let us look at replacing next. Sometimes, you want to replace values with easier-to-read forms. We are about to abbreviate long text values for gender. We create a mapping where male becomes M and female becomes Beth using replace. We show both the original and the shortened columns together. Running the cell now. This output shows how the sex column values are replaced with shorter abbreviations in the new sex_short column. Notice the one-to-one mapping of full labels to their abbreviations, demonstrating a clear and consistent transformation rule. This aligns with the lesson's intent to use map or replace when converting a single column based on a defined dictionary. Try this technique for other columns with long category names. Let us see how to replace multiple entries throughout the data frame using a single call. Here we target both yes and no values in the entire data frame. The replace method is powerful. It finds all yes, no and turns them into y or n. We see these new abbreviations reflected in the smoker columns. Running the cell now. Here, the code replaces all occurrences of yes and no in the data frame with y and n, respectively, focusing on the smoker column. Notice how all the no values change to n, which simplifies the data for easier analysis or visualization. This contrasts with map's best use case, as replace can handle multiple columns and values at once without needing a separate mapping rule for each. This approach is useful for standardizing text quickly. Apply, custom logic made easy. Use apply to run any custom function on a column or across rows. You can use it to calculate new features, flag values, or summarize data. Running the cell now. Let us learn by example. Let us add a new column that shows tip as a % of the total bill. We signal that we are about to use apply for custom calculation. The apply method goes row by row, dividing tip by total_bill. The result is a new column, tip %, which we preview here. Running the cell now. This output shows the original total bill and tip columns alongside the new tip % column we created using apply. Notice how the tip_PCT reflects the ratio of tip to bill for each row, illustrating how apply lets you easily compute custom metrics across rows. This demonstrates the lesson's intent to use apply for creating meaningful new features from existing data. Try using apply for other business ratios, like discounts or markups. Let us create a custom flag for customers who spend over $30. The comment explains our goal, to spot big spenders. We define a function that returns true if the total bill is over $30. This function can be reused if we need it elsewhere. We use apply to set true or false in a new column called big_spender. Let us preview the new flag column next to the bill amounts. Running the cell now. This output shows the original total_bill values alongside a new big_spender flag, which is false for all displayed rows since their bills are under 30. Notice how the apply function ran our custom logic row by row to create this Boolean flag, helping us identify high spenders easily. This demonstrates how apply lets you add meaningful summaries or flags based on custom criteria. Imagine how a business might offer loyalty perks to these customers. Apply can also be used column-wise, not just row-wise. We mention our intent, use apply across columns. This code calculates mean values for total_bill and tip. Running the cell now. This output shows the average values of the total_bill and a tip columns, calculated by applying the np.mean function column-wise, axis equals 0. Notice how the reply method simplifies running custom functions across columns, enabling quick summarization of key statistics, which is essential for feature engineering and initial data exploration. Notice how axis equals 0 means column-wise. You can use any custom function here. Let us get interactive and try mapping time of day using your input. This is a challenge. Create a binary value for time of day. We define a dictionary so that lunch becomes 0 and dinner 1. You get to type the column name with input, which should be a time here. We use map to create a flag column for time using your input. Finally, we show the before and after values together. Running the cell now. Here, the code creates a new binary flag column by mapping meal times to 0 or 1 based on user input, demonstrating how to apply custom logic simply with map. Notice how all dinner entries are correctly converted to 1 in the new time_flag column, showing how input-driven mapping can dynamically transform categorical data. This technique is powerful for feature engineering and data preparation in real workflows. Good job! Try using your own mappings with other columns. Combining techniques, replace and apply. You can mix these tools. For example, use replace with apply for even more flexible data cleaning. Try making custom replacements based on conditions next. Running the cell now. Let us see a business example of flagging generous tippers. Let us add a new flag for generous tips, over 20% of the bill. Here is the business scenario: recognize customers who tip generously. We use apply to assign or Y if the tip is more than 20%, N or otherwise. With print we show some examples of how this works. Running the cell now. This output shows the new generous column created by applying a condition to tip_PCT. Tips above 20% are flagged a Y, otherwise N. Notice all values here are N, indicating none of the first 5 tips exceed the 20% threshold. This demonstrates how apply lets us create custom flags based on precise conditions, enhancing data cleaning flexibility. How might a restaurant use this to reward great customers? Next, let us make our flags easier to read for reports or dashboards. We switch the letter codes in the generous column to full words for clarity. Using replace turns N into no and Y into yes. Value_counts helps us see how many customers fall in each category. Running the cell now. Here, we've used replace to standardize values in this generous column, turning N and Y into full words for clarity. The output shows the count of each category, revealing there are far more of no responses than yes, which is important for understanding the data distribution before applying further custom replacements. This step ensures cleaner, more readable data as we move into applying condition-based transformations. Try replacing coded flags elsewhere in your projects for better communication. If you find this tip helpful, like or comment on the video for more Pandas tricks. Recap and next steps. Map, use for series-level lookups and function mapping. Replace, use for mass value swapping, anywhere in your data frame. Apply, use for custom row or column operations. You can use these tools together for powerful, flexible data transformations. Now, go try mapping, replacing, and applying in your own projects. Running the cell now. For extra practice, map meal time to emojis or try replacing all missing values with zeros. Thanks for learning with us. If this helped you, please subscribe and comment your favorite Pandas trick below. Happy coding! Running the cell now.